Constant acceleration means
Mhm.
constant.
Like both velocity and time and constant.
Could you repeat your question?
Yeah, my question is, what is constant acceleration?
The rate of change of velocity is the same.
Rate of
Change of velocity.
rate of change of velocity is same, right?
Yes.
Uniform. Abdullah Mayed. How many Abdullah Mayed? Two Abdullah Mayed in the waiting room. Already one joined.
Maybe he's trying to join from two devices, or maybe one of them is fake.
Abdullah Mayed, I can see. Can you see one of the participants already joined, Abdullah Mayed?
No, doesn't show
So,
it yet.
okay, in
Maybe his
waiting,
internet is
in,
slow.
in the waiting room, you can see.
No, the host can see it.
Waiting room, Abdullah Mayed is there with one cartoon. Okay, I'm
The
accepting.
cartoon of a teddy bear, then that's Abdullah. If it
Okay,
has a cartoon of a teddy bear.
okay, I'm accepting one, and then let's see.
Yes, this one is the right one.
Mm-hmm. Then they cannot change the name. Okay, yesterday at last someone changed the name, Anmol, made the name Anmol, and they were annotating on the screen. So that Anmol is uh,
So that he
you
falls in trouble.
you see, and
The same thing happened with me last day in
yes.
Maths D class.
Okay, now it is not possible because I already, you see, Abdullah Mayed already joined with Teddy Bear, and then Abdul Munayem. Who is Abdul Munayem?
Sir, I think that's either
That's
uh,
Abdullah.
Sir, it's my
Abdullah is
account.
the one. Abdullah is
Okay,
the one which has a cartoon of a teddy bear.
yeah, this one is with
There's
us.
no Abdul Munaim.
Abdul Munayem,
Then
you,
that's fake.
yeah, we are not accepting without academic name. Now, you told it correctly that constant acceleration means rate of change of velocity is
It's
same, right?
uniform.
Is uniform, is same, it's steady. So right here, this one in your copy, huh? In your
Sure.
copy, you write this information, what you said, because we know many things, but
Sir,
Before the exam, I forget everything.
sir,
we always cannot remember everything, recall everything easily, right? So
sir,
if it
Yes.
is written, then it is easier for us to remember, recall. Yes,
sir,
yes. Raise
sir.
your
I
hand.
have printed this worksheet. Where
Yeah,
do I need
very
to
good.
write?
That's awesome. That's awesome. There you write. That will be wonderful. If you have the notes with you printed, then on the printed notes you write. No problem. Then constant acceleration means rate of rate of
Change
in
of velocity.
you can give more specific rate of increase of velocity.
Positive change.
Yeah, rate of increase of velocity. Rate of increase of velocity rate of increase of velocity is uniform. Okay, rate
Yes,
of
sir.
increase of velocity is uniform. That one is constant acceleration, and constant deceleration you can make now. That will be rate of decrease of velocity is uniform, right?
Yes.
So write that rate of decrease of velocity is uniform. So we got both are straight lines, right?
Yes, sir.
One is with positive gradient, another one is with negative gradient.
Negative gradient.
Okay, and later on we have non-uniform, non-uniform acceleration and non-uniform deceleration. Acceleration and deceleration, you are very clear. Acceleration means velocity increases, right?
Yes.
Yes.
And deceleration means velocity
Velocity
decreases.
decreases.
So in both the graph is very much clear to you that why it is acceleration and why it is deceleration. Now what you have to understand why it is non-uniform. Non-uniform deceleration
The
will
acceleration
go,
changes,
yeah,
right?
Not in
yeah.
a straight line.
The non-uniform deceleration comes if the uh, rate of decrease of velocity is not uniform, is not same. Look, uh, if you are thinking about this time, if you think this one is 1 second, then this is another second, right? So in the first second, the way velocity is decreasing, in the second, it's not like that, right? You see,
Yes.
if you consider here one value, it is, for example, it is 5, then 5 to, almost 2, we are getting in 1 second. That means in 1 second, the velocity is decreasing by 3. But after that, it's not increasing that, it's not decreasing that way. It's, if you think here is 2 seconds, then it's only decreasing maybe 1 meter per second. Is it clear?
Yes.
So this way you should analyze whenever you are getting the graph. You should think deeply. I think if you are trying, you can do it. Mashallah, you are very intelligent, all of you. So, uh, non-uniform deceleration, you understand. Now, for non-uniform acceleration, we are having here two graphs. Both are non-uniform acceleration.
Yes.
Acceleration means
Rate of
increase
change
in
of
velocity,
velocity.
increase of
Yes.
velocity, right, with time. So, in if you think of the pink color one, huh? This one is pink color, right? The lower one,
Yeah.
and the upper one is almost purple, right? Purple color or violet. So the lower one, the pink color one, you see there is increase of velocity with time, right?
Yes.
Velocity is increasing with time. So it is acceleration. It is clear to us. And
Yes.
as we are not getting the uniform rate, we are not getting any straight line here. That's why it is non-uniform, right? Is
Yes.
it clear? The lower
Yes,
one
sir.
we
It's
discussed.
easy.
Now the upper one also we have for a while you see there is a straight line. Like till here we can consider, yes, this one is going with
Constant.
constant acceleration or uniform acceleration. But after that
It's
the part
non-uniform.
part of the graph, you see, is the way it was increasing here.
Um,
Here it
in
is
this graph,
increasing.
why are there two lines?
Anyone is talking?
Why is there two lines?
Hello, anyone is asking me anything, or you
Navisa
are,
was asking something.
Lamisa, are you asking me, or you are talking to someone in your house?
Sir, sorry, sir. I was asking you.
Okay,
Um,
you are asking me about non-uniform acceleration.
yes, it's
Which one, the pink one or the uh, purple color one?
a pink one.
Pink one, okay. So what you asked me, can you say again? Hello, what you asked me, Lamisa?
Navisa, could you please repeat your question?
Lamisa.
Could you repeat the
I think
question?
she has some internet problems.
Okay, so please uh, tell her that we have the recording, right? Even if there is internet problem and due to internet problem, she is not getting our sound, she can get it later. Okay, so here we were discussing the purple color one. You see this one. Here also we are having increase in velocity, right? Velocity is increasing, but it's not increasing the way it was increasing before, right?
Yes.
So we can say here we are not getting uniform. We are getting here non-uniform acceleration. For the whole part of the graph, there is acceleration, but it's not uniform. It is not constantly increasing. Okay, in different part of the graph, it is increasing in different way. Is it clear? Hello?
Yes, sir.
Okay, very good. So here we got, you see, fifth point for curves. It means that the acceleration of the object is changing. Okay, if it is curved line, then acceleration of the object is changing. It's not constant. Okay, for a straight line with positive gradient, it means that the object is accelerating. This one, the first graph. And then here for a straight line with negative gradient, it means that the object is decelerating. The second one we discussed. Okay, so
Yes.
these all are clear to you. Now what they said at the last point, the area under the graph is a change in the displacement. We are going to discuss later in next part. Okay, we will discuss it
Okay, sir.
later on. So for all these discussions we have right now, do you have any questions? Anyone?
No, sir.
Sir,
Yes. Yes. Anyone? You have any questions? Mithila, Bhumi, Azrila Bhumi, then Azwad, Anmol,
Hello.
Badsha,
Why
Lamisa,
is everyone so
Maruf,
quiet today?
Maruf, Anmol, yeah, Taki,
Yes, sir.
Mithila.
Sir, not yet.
Sir, I understood.
Yeah, if you don't have any questions, then I'm going to next one. Okay.
Okay, sir.
Sir, you
Yes.
can go to the next one.
Okay. Thank you. Thank you for your cooperation. MashaAllah, you are learning a lot. So here we are getting one graph where we are showing everything together. You see in this graph, we have acceleration, we have deceleration, we have constant speed. Look, this one is acceleration, right? Constant acceleration, isn't it? Hello. This
Yes,
is
sir.
steeper straight line. We have constant acceleration. Another steeper straight line, we have constant acceleration, but there is more gradient, right? For the next one. So the more gradient means the acceleration is more, right? Rate of change of velocity is here more than before. Okay. The first one, the rate of change of velocity we have. Second one, we have greater change of velocity, right? Okay, so
Yes, sir.
so for velocity time graph, we can decide, we can conclude one thing from these two, first one and second one. These two graph, if we compare, then we can decide one thing. We can write the steeper the velocity. Can you write on your copy?
Yes,
Or
sir, I am.
Taki, you can write on your notes, printed notes. The steeper the velocity time
Sir, I
graph.
am writing.
Yes, right, please. The steeper the velocity time graph, greater the acceleration. So is it clear, all of you?
Yes, sir.
The steeper the velocity time graph, greater the acceleration. And now it's also written here. Look, we also gave here in shaded box. We have the information. Slope upwards gradient shows acceleration. Steeper gradient shows quicker acceleration. Is it clear?
Yes,
Quicker
sir.
Yes,
acceleration
sir.
means greater acceleration. And we have here the third part, that is showing you horizontal line. The horizontal line means it is parallel to time axis. Okay. So this
Yes.
horizontal
Equal
line,
to time
you
axis.
see, if you observe, if you think, listen, everything you have to think. Otherwise, you will not understand. You will forget. Now you are listening, you will forget tomorrow. But if you want, you understand clearly, you never will forget. You can make it. Look, with time, the velocity remains constant, right? Velocity is same. So that's why we are saying it constant speed or constant velocity. Is it clear?
Yes.
Sir.
Yes, sir.
Now, the last part, you see already just before this graph, we had this discussion that if it is negative gradient, right? Straight line with negative gradient, that one is giving us constant deceleration. Okay? So slope downwards gradient shows constant deceleration.
Excellent.
Is it clear? Okay, so
Yes, sir.
Yes, sir.
this deceleration can also have, like acceleration, more gradient, less gradient. Okay, if the gradient is more uh, for deceleration, then we can say there is greater deceleration. Is it clear? I'm
Yes,
drawing.
sir.
I'm drawing another line here. Look, you can understand it easily then. Here, look, I'm drawing here another line. This way. Okay. So the line I drew just now, this one has a greater gradient, right? This one, you see,
Yes.
this one is less with less gradient, the red one, and the blue one has greater gradient. So the greater gradient one has greater deceleration. That means it will be stopped earlier. Okay. Uh, this car will slow down faster and it will be stopped earlier than this, right? You see, we are taking less time here to stop the car.
Yes,
Is it
sir.
clear?
Yes,
So,
it's easy.
yeah, very easy. So, Yeah, thank you for your comment. That you need more explanation, right, Anmol?
Yes, sir.
Okay, very good. Look, if you compare these two lines, the red one already have and the one I drew. So if you compare these two lines, you see the one I drew later, that one has more gradient, right? It is more steeper,
Yes.
Yes.
and it's taking less time to reach in the stop position. When it is here, that means your velocity is zero, right?
Yes.
Here also velocity zero, here also velocity zero. So the blue line is showing you your velocity is becoming zero earlier than the
In
red
next
one.
time.
Yeah, earlier than the red one. So we can say the greater the gradient, more the deceleration, right? Here.
Yes, sir.
Yes.
Yes.
And the car will stop earlier. Is it clear?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
so if it is clear, should we write it or you can remember it?
We can
Write it.
remember
I
it.
wrote it.
You can
I
remember
already
it.
wrote it.
And there will be recording also.
Yeah, you can remember it and you can link with the left side one. Okay, same thing. Yeah, the
Uh,
steeper the
the
velocity time
greater
graph, greater
the
the acceleration. Here it is opposite.
then
The steeper the velocity time graph, greater the deceleration. Huh? Here the slope is downwards. That's why it is deceleration.
It's the same word,
so the
but
sloper.
it's deceleration
This
instead of
slope is
acceleration.
this slope is with positive gradient and this slope is with negative
As
gradient.
steeper the velocity
Yeah,
time graph, greater the deceleration.
yeah. Is it clear? So can
Yes,
we go
sir.
to next part
Yes, sir.
or we will stay here some more time?
I think we can go to the next
Yes,
part.
sir.
Okay, thank you.
Should ask all the students.
Thank you. Thank you so much. Now we are going to an awesome thing today. We have time, right? We have 15 minutes around, so we are
Yes,
going to
sir.
learn a wonderful thing today. You will love it, all of you. And that is uh, calculating area under a velocity time graph. Yeah. So this graph is giving us many things in a small space. We can represent lots of things. We can get acceleration, we can get deceleration, we can constant speed, uniform acceleration, non-uniform acceleration. Also, this speed time or velocity time graph gives us distance. If you can calculate the graph, the area under the graph, then you can measure the distance, how much distance you travel, you can measure from speed time graph. How it is? By using a simple technique, you will take the area under the graph. So here, uh, this object is traveling in a way that in 5 seconds, it is going with constant acceleration, and after 5 seconds its final speed is 50, 50 meter per second. Do you understand what I'm saying? Hello?
Yes, sir.
Yes, sir.
So
So 5 to
yeah,
5.
okay, listen, wait. In 5 seconds the object reached at velocity 50 meter per second and the initial speed was zero, right?
Yes.
In 5 seconds its speed increases to 50 meter per second. So we are getting here steeper straight line with positive gradient. That means the object is going with constant acceleration, right?
Speed.
Constant
Yes.
acceleration, not speed, constant acceleration. The speed is increasing with time.
Yes.
Yes.
Okay, in 1 second, this is going to 10, in 2 seconds, 20, in 3 seconds, 30. That means the acceleration is 10 meter per second square. Constant acceleration. Now, uh, we are calculating the distance. Our concern is calculating the area under velocity time graph or speed time graph will give us distance traveled. You see, the area under a velocity time graph was distance traveled. Now, for this graph, if you are taking the area under this graph, you are getting one triangle, right? Isn't it?
Yes.
Yes,
So,
so we are using the
yeah,
Yes.
triangle
yeah,
formula.
area of triangle you can calculate with the formula half into base into height, right?
Yes.
So your base is here, this one, right?
I
Base is giving you 5 seconds, and your height is giving you 50 meter per second, right? 50
yes.
Yes.
meter per second. So we are writing the values with unit. Then it will be more understandable to us how this graph is giving us distance. Look, your 5 is in second, right? The base, isn't it?
Yes. This is the
Yes,
time.
sir.
Yeah. So we are getting here.
Height is the velocity.
Yes, very good. So we are first getting 5 second, right?
Yes.
I'm writing the unit here. Look, then we are having meter per second, right? 50 meter per second, isn't it? Meter per second. So if you are calculating, you see
Sir,
first
what is this S star?
S multiplied.
Sir, square.
R means multiply.
Yeah, star means multiplied. Look here, we have 5
Meter
multiplied
per
50,
second square.
5 multiplied by 50, right?
Yes.
So
5 square
5
50.
with 5 we have second, right? It is time, isn't it?
Yeah.
With 5
Yes.
we have second, so we are writing here second, and with 50 we have meter per second.
Meter per second.
So according to cross multiplication rule, if you have S multiplied by M by S, then your this S and this S will be cut.
So there will be M.
So what is left? M. M is the unit of distance, right?
The
Distance
distance.
traveled.
M is
Distance.
the unit of distance travel, right?
Same thing.
So you got the proof that if you are calculating the area, you are getting distance. Is it clear now?
Yes.
Yes, sir.
So mathematics is helping us to understand how we are getting distance from velocity time graph. I think all of you understood right now and convinced
Yes, sir.
that velocity time graph, if you are taking the area under the graph, then it's giving us distance. Okay,
Sir, now.
is it clear now?
Yes, sir.
Okay, so we will write here 125 meter distance traveled, 125 meter. Is it clear?
Yes, sir.
We got here
Yes, sir.
half. We got here half, then base 5, then your height is 50. If you calculate, it is coming 125. So the distance traveled uh, in 5 seconds, it is 125 meter. If you are done with this part, then we can proceed. If you have any questions, you can ask me.
No, sir.
All of you are clear.
Yes,
Yes,
sir.
sir.
Yes, sir.
So thank you so much for your patience, your attentivity. Now we are going to next part. We are now applying the learning. Already we learned how to use the area under the graph. Now we are going to apply that one in our next step. You will help me, okay? All of you.
Yes, sir.
Now, look, we are having now another graph. This graph has three parts. The first part is showing you part A, constant acceleration. Then the second part is showing you constant
Part
velocity.
B.
Yeah, constant velocity, part B. And the third part is showing you constant
Acceleration.
deceleration. Part
Deceleration.
C. Yeah, deceleration. Until it is becoming at rest position after 70 seconds, it is decelerating, right? Constantly. That's why there is a
Yes.
straight line. Now, today we don't have so much time. You will help me as much as possible. We will complete. My first question is, what is the distance traveled by the object in 10 seconds? My first question. You also write in your copy the first question. First question is,
100 meter.
what is the
100 meter.
distance? Can you calculate it on your copy?
It's 100.
Distance traveled. You write the question also, huh? What is the distance traveled by the object in 10 seconds? Okay. So the distance traveled here, how much?
100 meter.
100 meter.
100
How it
meter.
is? How it is? Can you tell me
Base
the
into height
solution?
divided by 2.
Half
10
into
times 20 divided by 2.
base into height, right? The formula.
Yes.
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 And we are getting here half times base is how much? 10 second, right?
10.
10 second. And our height is how
Height is
much?
20.
20. 20 meter per second. Then the answer is coming
100
100
meter.
meter.
meters. Very good. Very good. Awesome. Now, second question. What is the distance traveled? I'm writing the question. What is the distance? What is the distance traveled when the object is at constant velocity, right?
Yes.
Yes.
Constant velocity.
40 meter.
40 meter.
40 meter.
40 meter.
How 40 meter?
Area of rectangle formula.
I find here 400.
What? Oh yeah. Oh, 20 times 20.
Hmm.
Sorry,
I find
apologies.
here 400, right?
Yes.
Yes,
Can you
yes,
write
yes.
it? Can you calculate this correctly? Length multiplied by breadth, right? Area of
Yes.
L into B.
rectangle.
Yes.
Area of rectangle. The formula is
20
length
times 20.
times breadth.
So it's by 20 into
So
20.
we are having
20
it
times 20.
20. 20 times 20.
20.
Then 400
100.
meters. Awesome. We have only 3 minutes, right? Can we do the last part?
Yes, it's
Yes,
Within
easy.
sir.
3 minutes? Can we try?
Yes,
Three.
sir.
Yeah, sure.
Okay. So, what is the distance traveled during deceleration?
Distance.
800 meter.
800 meter.
traveled during deceleration. Are you sure?
Sorry, it's
Yes,
400.
sir.
400.
400. Oh, triangle.
Yeah, you were listening to me, right?
Yeah.
No,
Are you sure?
Yes, I
I
got
did
you
one
red-handed.
mistake,
It's 400.
Do it. Then you say
but
why you are in
Arpita,
so
you made the
hurry.
Yes, it's
mistake.
400. I was just testing someone,
Yeah.
whether he was copying me.
Half into
Why do
base
you
into
test
height
everyone?
equals, what is the base here?
Half base is 50. No, wait,
40.
40.
40.
See, I know.
Okay, 40.
Yeah.
Then
40 times
height
20.
20. Okay, then
Equals
400,
Hey, 40
right?
times 20.
400 meters. So you can get it right this
Yes.
way. Hello.
Sir,
You,
number 3,
Yes.
can you explain me?
yeah, speed is here. You see 30. At 30, it is 0, right? 0 to 20. So 20. Height is 20. And the time is from 30 to 70. It is 40. Is it clear?
Yes,
So
sir, done.
all of you clear this one? Lamisa, Mithila?
Yes, sir.
Yes, clear.
Oh, sir, like why should we only take 40? Like we can.
Okay, 40 means the deceleration starts from 30 seconds and it ends to 70 seconds. So 70 minus 30 is 40 base. Is it clear
Oh,
now?
yes, now it's clear.
Okay, thank you so
Sir,
much.
time up.
Thank you so much.